A peer-reviewed study proved temperature doesn't control creativity. Every developer who copy-pasted temperature equals 0.7 from a blog post, they got it wrong. GPT has 3 parameters that shape every single response: temperature, tokens, and memory. Most developers treat them like mystery dials: set temperature to 0.7, max tokens to 2000, and hope for the best. But getting these wrong costs real money, breaks your apps, and makes your AI unpredictable. I'm going to give you the real mental models, backed by research, not blog post folklore. And by the end, you'll have a config cheat sheet that actually makes sense. Quick orientation before we dive in. Every time you call the OpenAI API, you send a payload. That payload includes your messages, your conversation history, but it also includes parameters that control how the model responds. Think of these as dials on a mixing board, and right now, most developers are flying completely blind. Let's start with temperature, the most famous parameter and the most misunderstood. Here's what most people think. Temperature controls creativity. Set it high, the model gets creative. Set it low, it gets precise. Makes sense, right? Wrong. A 2024 peer-reviewed paper asked this exact question: is temperature the creativity parameter? The answer was brutal. Temperature is weakly correlated with novelty, it's moderately correlated with incoherence, and it has zero relationship with originality or cohesion. The creativity dial framing is folk wisdom dressed up as documentation, and your AI app has been running on it. So what does temperature actually do? Here's the real mental model. Every time the model generates the next word, it calculates a probability distribution across its entire vocabulary. Tens of thousands of words. Each word gets a raw score. Temperature divides those scores before they're turned into probabilities. At temperature 0, the highest scoring word wins every time. Deterministic, predictable. At temperature 2, those scores get flattened. The gap between words shrinks. The model picks more surprisingly, sometimes brilliantly, sometimes incoherently. Setting temperature to 2 for creative writing almost always produces gibberish. Think of it like a DJ mixing board. 0 is locked to the beat, 2 is full improvisation. Your task determines the right setting, not a universal number. Here's the research-backed breakdown. For code generation, classification, and data extraction, use 0 to 0.3. You need reliability, not randomness. For general chat and customer support, 0.6 to 0.8. The old 0.7 recommendation isn't wrong, it's accidentally correct for this use case. For creative writing, brainstorming, marketing copy, 0.9 to 1.2. And one critical finding from 2025 research: large models like GPT-5 are resilient to temperature changes. But small models? They hallucinate fast above 1.5. Know your model, and stop picking 0.7 by default. Next, tokens, and I promise this is more interesting than it sounds. Most developers think tokens are just words. They're not. A token is roughly 4 characters, or 3/4 of a word in English. Temperature is 2 tokens. Cat is 1. Code and non-English languages often tokenize worse. More tokens, more cost. Now, there are 3 token buckets you need to understand. First, input tokens. Everything you send, system prompt, conversation history, user message, all counted here. Second, output tokens, the model's response, usually 2 to 4 times more expensive per token than input. Third, context window, the total limit, input plus output combined. GPT 5.4 supports 1 million tokens, but here's the trap: a bigger context window doesn't mean free memory. You might still be using max tokens in your code. It still works for standard models, but for reasoning models, O3, O4 Mini, and GPT-5, OpenAI deprecated it. The new parameter is max completion tokens. Here's why it matters. Reasoning models generate hidden thinking tokens before their visible response. Those hidden tokens don't count against max completion tokens, only the visible output does. So if you're capping max tokens on a reasoning model, you're not controlling what you think you're controlling. The model might spend 10,000 hidden reasoning tokens before answering. Your cap doesn't touch those. Update your code. Now here's where memory gets genuinely weird. You think GPT remembers your conversation. It doesn't. The API has 0 memory between requests. 0. Let me show you what's actually happening underneath every chat message you send. Every single API call is completely stateless. There is no server storing your conversation, no database linking your messages across requests. When you send a message to the API, you send the entire conversation history every single time, every previous message, every AI response, all of it bundled into the messages array and resent from scratch. ChatGPT's memory feature? That's a wrapper that retrieves summaries from a storage layer and prepends them to your system prompt as tokens. It's not magic, it's clever prompt injection, and this has massive implications for your app's cost. Here's how it works in practice. The messages array has three roles: system, user, and assistant. System is your instruction prompt. User is the human's input. Assistant is the model's previous responses. Every turn, you append to this array and resend the entire thing. As conversations grow, your input token costs grow linearly. A 10-turn conversation costs 10 times more in input tokens than a single-turn request. And when you hit the context window limit, the model can't respond. It doesn't gracefully forget old messages. It errors. This is the #1 silent budget killer in production AI apps, and nobody talks about it until the invoice arrives. So how do you handle memory like a professional? 3 strategies. First, sliding window. Drop the oldest messages when you approach the token limit. Simple to implement, but the model loses early context, sometimes critical system instructions from the start of the session. Second, summarization. Periodically ask the model to summarize the conversation so far. Replace the full history with that summary. You keep the gist, you slash the token count dramatically. Third, external memory with tools. Build a database. Give the model a retrieval tool. When context is needed, retrieve it and inject. This is RAG for conversations, and with MCP, you can wire this up with a single server. This is the professional approach for long-running production agents. Let's pull all 3 together. Your 2026 parameter cheat sheet. Temperature, 0 to 0.3 for precision tasks. Code, extraction, classification. 0.7 for general chat. 1 to 1.2 for creative work. Never exceed 1.5 on small models. Tokens, always use max completion tokens, not max tokens, especially for reasoning models. Budget aggressively for input. A system prompt plus 10 conversation turns can consume 40% of your context window before the user types a word. Memory, never assume the API remembers anything. For anything beyond 3 turns, implement a strategy. Sliding window for simple apps, summarization for medium complexity, external memory tools for production agents, 3 parameters, 1 cheat sheet. Ship better AI apps. Temperature, tokens, memory, these are the foundation of every AI app you'll ever build. Get them right, and your costs drop, your responses improve, and your apps scale. I'm dropping a full series on building production AI agents next. Hit subscribe so you don't miss it.